help people figure out how to build websites in Haskell. I'm Ryan, and I work. My main job is working for a company called SchedgeMe that is also building a big commercial scheduling application in Haskell. So very near and dear to my heart. All right, so to get started, this is a web app Hello World in Haskell. It's pretty simple. You can just check this out and Cabal install it and run it. The first thing that you do when you're building a website in Haskell is you define the site object. And this is very, very simple. All this one does is whenever it gets any request, it responds with Hello World. That's a pretty darn simple website. And then the Snap framework provides us with this quick HTTP server, takes our site, serves it. Anytime an HTTP request comes in, it invokes our site handler, and it just sends that text that it would normally send. And so this is the simplest possible website that you can write in Haskell with Snap. And I'm going to show you how to build this all the way from where it is now into basically a sort of a bit.ly clone, a URL shortener. All right, so this is Haskell. We use types. You don't have to write them. If you write the previous slide, this works just fine because Haskell can infer the types for all this stuff. But it's always helpful to think about what exactly we're writing, and this is what the type system helps us do. Doug will go into some more detail in his talk about how exactly the type system can help you build more reliable code, can help you build it more efficiently, make better use of your time, and reduce coder error. So here we have two actions. The first one is a snap action. A snap action is something that responds to a web request. So anytime you see something like, with this snap type, that's going to be responding to a web request. And it can do things like it can write text to the request, it can read the headers of the request, it can do all the things that you would normally do when you're trying to, serve a web page. The I/O action is main. I/O is a type that we use in Haskell that represents any kind of action that can interact with the outside world. So main, just like main in C or a lot of other languages, is the entry point to your program. And it's an I/O action. It can make network connections. It can read and write files. It can do pretty much anything that any other programming language could do. It can even call out to other programming languages using the foreign function interface, just like lots of other languages can do. So I/O is sort of where, if you want to do anything, that's the kind of action you're going to be doing. And what quick HTTP serve does is it kind of intermediates between these two different kinds of actions. It takes your snap action, which is a very specialized kind of action for responding to a web page, and it translates that to I/O. It handles managing your connections, anything that it needs to do to actually turn that into a program. Now, when you've got an action in Haskell, just like when you've got a function in any other language, you have a return type. These functions both are basically void return functions, and the way that we denote that in Haskell is with this open and close parenthesis, which we call unit. That'll be familiar to any of you who use other functional languages like SML or Scheme, Lisp. This is just basically the same as void. It means that we're not returning any result from these actions. All right, so we've got a very simple application here, and I can show you what it does. This is it. That's the whole thing. It's not even serving HTML. This is just plain text. The browser will just render it like this. I'm sure you've all done this at one point or another, just trying to get something working. Now, in Snap, we can build our entire application as just a big Snap action. But that would be a lot like building your entire C application as a giant main function or something like that. You don't want to do that. what you want to do is try to break it down into more modular, reusable components. And the way that we do that in Snap is we build these things called snaplets. Snaplets have their own environment. They have an initialization routine. They can do cleanup after they exit. And one really important thing they can do is they can contain other snaplets. So you can make these sort of nested hierarchies of snaplets. And that's a way that you can take a website or some part of a website that someone else has made, and you can include it into your website. There are lots of other platforms that do this kind of stuff. It's like similar to the way Java has its enterprise NetBeans and things like that. But basically, this is something that we would want to do if we want to build a website in a more modular fashion. So that's the next step in building our URL shortener. We're going to translate this into a snaplet. It's going to do exactly the same thing, but it'll be in this more modularized form. So this is what it looks like as a snaplet. The first thing that we do is we declare the snaplet's environment type. In this case, it's called memoize. That's the name of our site. And it doesn't contain anything. This is just a bare, blank environment. And at this point, we're just sort of using it as a name for the snaplet. So the next thing that we're going to need to do is we're going to need to make an initializer for it. This is another kind of action. It's not responding to a web request. It's just doing the initialization of the snaplet. And so snaplet init is a kind of action that is designed to initialize a snaplet. Now, this is parameterized by the kind of snaplet that we're building. So this is a specific action to initialize our memoize snaplet. It also returns an initial memoize snaplet environment. So we've got the action type, and then we've got the return type again. This is a common pattern in Haskell. The last thing that you see is going to be the return type of the action. All right. So in order to make any snaplet, we use this function called make-snaplet. Not too surprising. What it takes is the name of the snaplet. It takes a description of the snaplet. And these two things are used to annotate log files. They're human readable. They don't get displayed to your end user. But if somebody else is integrating your snaplet into their application, this is going to be really useful for them. It also takes something that can be used to create files and that kind of stuff, but we're not using that here, so we just pass nothing instead. This is another common pattern. Nothing is kind of analogous to null in other languages, but it's a little bit different. Here we're just going to pass nothing because we don't have anything that we need to do in this position. The last argument to make snaplet is another action. And one thing that you can do with actions, and it kind of makes sense, is you can put them together. So you can do one action and then do another action. That's what we use this do syntax for in Haskell. It's just like a block syntax where you separate things with semicolons in a lot of other languages, JavaScript, C, everything like that. But this is just going to do these two lines that come after it, and the last one is the return value. So the first thing that we're going to do, and this is the only really important thing we're going to do in this snaplet initializer, is we're going to add our handler. The index handler is going to be what gets invoked every time the user tries to load a page. Okay? So add roots takes a list of handlers, and each one is associated with its path. So we say the path is nothing. That's going to be the root of the website, and that's going to go to the index handler. Pretty straightforward. Then we return this empty environment. We construct it just with nothing in it. And that's going to be the result of this overall memoize init function. Now, one thing that I haven't really explained yet is what this $sign means. This is something that can be a little bit confusing when you're first getting into Haskell. And if any of you have looked through Haskell stuff, I mean, I know we have some people who are really new here and other people who know everything about Haskell here. But $sign is a little bit interesting. It's basically like an open parenthesis, and it goes as far to the right as it possibly can. So we could have written this using parentheses instead. And so that first one would go all the way to the end of the do, and the second one just goes to the end of the line. I just want you to know how this is so that when you're reading the code, because I'm going to keep using it throughout this presentation. But in Haskell, we don't really love parentheses like some of our compatriots do in other languages. So we tend to stick with $sign when we can. All right. So once we get into actually serving a web request, the index handler is what is going to get invoked. And in this case, it's doing exactly the same thing as the site variable was in the last program, and that's just to write out some text. Now, you can see that the type has changed, and that's because we're in the snaplet context. Snap is a very basic type of action, which doesn't have any of this potentially customized or initialized environment. It can respond to a request, but it doesn't know anything about your particular application. So when we have this handler memoize, this is a kind of action that runs in our memoize application's context. Now, you may be wondering why memoize is listed twice here. It's a little bit confusing and maybe a little bit verbose at times, but there is a good reason for it. The first one tells us what the entire application we're running in is. This is kind of like the root of the website. The second one tells us which snaplet this handler itself is a part of. So in this case, this is a handler that we're writing at the full application level, so it's the same. But if you wanted to write a handler that other people could reuse in their own websites, then you might write it a little bit differently, and they could end up running it in its own context, but in their application. So we're going to always use the handler memoize form in this particular website, but this is just something that I want you to be aware of. It can be a little bit more reusable than this. All right. The last thing that we need to do is take our snaplet and get it back into a suitable form for quick HTTP serve to run. The way we do this is we use run snaplet. Run snaplet can do a lot of stuff. It can provide some more things to the snaplet, and it provides a couple of different output parameters. I'm not going to go into exactly all the potential there, but we can get the site variable out, and this is going to be more or less equivalent to the site that we had before, and then we can just serve that again. And this main function, we're done with this. We're not going to change this again for the rest of this presentation. All right. So the next thing that we want to do is actually get some HTML into this thing. At this point, we've just been sending plain text to the browser and hoping that everything works out. It's much better to actually serve a web page when we're writing a web app. So the way we're going to do this is using the Heist template system, which was written by Doug, who's giving the next presentation. So the first thing that we need to do is we need to give the Heist snaplet somewhere to store its environment. It's going to need to load templates and cache things and do all kinds of other stuff that we don't particularly care about how it does that exactly, but we do need to give it a sandbox that it can live in. So we're going to add it to our snaplet environment. So we just say, give snaplet Heist, a variable here. Now, the next thing that we need to do is we need to provide a lens. Our good friend Ed Komet wrote us a fantastic lens library. He presented it at the last NY Haskell Meetup. And what this basically does is gives us a whole bunch of functionality that makes it really easy to access and modify the different components of our environment. So that's going to generate something called Heist right there, which is based on this component of our environment. So every time you see Heist, that's referring to this field _Heist, which is part of our environment. And so by giving this lens to Heist, we're enabling it to get and set its own environment. And that's how that's what this instance declaration is for. It basically just informs Heist of where it can store its stuff. All right. The next thing that we need to do is initialize Heist. We need to say, first of all, we're nesting the snaplet in our own snaplet. We're going to give it a root URL. If it needed to create any of its own pages, it would create them under this URL. We need to give it the lens that points at its environment within our environment. And then we need to actually invoke its initialization function, Heist init. And that'll be different for any different kind of snaplet that you're nesting in it. The nest snaplet component, that'll be the same, regardless of what snaplet you're nesting. But this one, you would just need to look up the documentation for whatever functionality you want to include. It'll explain what the arguments are. In this case, we need to give it the name of a directory where it can find all the templates for your application. We called it templates. All right, the next thing that we need to do in the initializer is take the result of that and put that as the initial Heist environment. That sets up our environment so that we can access Heist. It's all good to go. All right, now what that enables us to do in our index handler is instead of just writing some static text out to the web browser, now we can render a template. So we created a template called index. This is what it looks like. And when we call render index, it'll spit that out to the browser. This is very simple. This isn't showing off any of the power of Heist yet. But this is just taking a raw HTML document and spitting it out to the browser. All right. So what this looks like is that. You can tell by the fact that the font is slightly different that it's now HTML. OK. Slow but steady progress. Now, the next thing that we need to do is we need to serve some static files. This is how we're going to make our website look nice. We need CSS, we need images, all that kind of stuff. So in Snap, this is very, very easy. All we got to do is include this additional library, the file serving library, and then we just add a route. We just say anything going to /static is going to get served out of the static directory. So here's our new HTML file. I just sort of tossed some stuff together. And you can see all the highlighted components. Those are static resources that we're going to be serving out of the static directory. And that's pretty much that. I mean, you all have seen HTML, so I'm not going to go through any of that. But what it looks like is that. All right, now we're starting to look like a website. So the next thing we need to do is make it so that we can actually receive some sort of data from the user. That's going to be pretty important if we want this website to be useful at all. We don't need to change anything about our environment or the libraries we're using in order to achieve this. All we need to do is try to get the parameter. We're going to call the parameter the URL. And in this particular case, we're looking for this parameter. GetParam is a function that it'll return a maybe value. This is where we get that nothing value from. So in Haskell, you don't have null and everything else. If you want a type to be optional, you have to specifically make it optional. And the way we do this is with the data type maybe. So we use case to unpack a maybe value into just the value, which is this first case here. And if the value does exist, then we'll redirect the user to that URL. We're just doing that so that we can verify that we've received the data. It's not a particularly useful way to do things, but it lets us test that we've received it. And then if we don't get any URL parameter, then we're just going to render the index like usual. So we also don't need to make any changes to the end of the file. We don't need to change the initializer or anything like that. Pretty straightforward. What we do need to do is change the HTML to add a text box. This is a very straightforward HTML form. There are fancier ways of building up forms in Snap, but this is the simplest one if you're familiar with HTML. So it's a form with a text box and a submit button, and that's pretty much it. So what we're going to do here, if I go to the next one here, we can go to Google. I don't think I have internet right now, but yeah. Anyway, it redirects to Google, and so that's the functionality that we're seeing here. That's that. So now we've gotten some data from the user. Now what are we going to do with it? So the first thing that we might want to do is have some way of giving feedback to the user. So what we're going to start by doing is adding a splice. This is a Heist concept that enables us to dynamically change what our web page looks like. This is a very simple attribute splice. It's an attribute called main text box that I created, and it'll get replaced with some data depending on what happens in the application. So the first thing that we need to do is add somewhere in our environment for the data to come from. That's going to be a maybe text, because we won't always be giving a response. And I'm calling it main text box contents. Now, instead of redirecting the user when we receive a URL, what we're going to do instead is we're going to save a string that we're going to respond with into the main text box contents. And then we're going to render the index just like we normally would, and the splice will kick in. Now, of course, in order to make this work, we need to actually define the splice in question. So the splice is going to be a handler action, just like the index handler itself, because if you remember how we can join together handlers or actions of any kind using do, when you have an action that's a handler, it's not necessarily the entire handler, it's just part of it. So we've got this handler action, and what it's going to do is it's going to look at our environment, and it's going to return a series of attributes to replace itself with, right? So this is an attribute splice, and it's replacing itself with attributes. Now, the first thing that it needs to do is retrieve the value of this variable, the main text box contents. And if there is such a value, then it will replace itself with a value attribute. And for those of you who know HTML, it's, if you provide a value, that's what the text box will start with when the web page loads. If there isn't any response text, then it will replace itself with nothing. So this is what it'll look like if we do get a URL, and this is what it'll look like if we don't. Now, the final thing that we need to do is we need to actually install this splice in Heist. And we do that by modifying our initializer so that it modifies the Heist state on initialization. It'll bind the attribute splices here. And all we're saying here is that if you find an attribute called main text box, then invoke this main text box attribute splice. We also need to initialize the main text box contents to a sensible default value. In this case, nothing. All right, so now we can see how this actually works. So it'll replace that text for us. And if you've ever used any of these other URL shorteners, that's typically how they give you feedback. You'll enter something, they'll replace it with the shortened URL, and that's what we're going to build up to. All right, so the next thing we need to do is we need to actually save the data that we've received. This is the key part of a URL shortener. So we add a few libraries here. The most important one here is the Postgres simple snaplet, another one of Doug's creations, which makes it very easy for us to integrate the Postgres database. Obviously, I'm not going to go into setting up the database. That's something that is beyond the scope of this talk. Now what we need to do, just like with the Heist template, we need to make a place for Postgres to keep its environment. It's going to have a connection pool. It might have some other information that it needs to keep track of. And so we need to give it a place to put that. So in our environment, we create the Postgres snaplet variable called db. Make lenses will automatically make a lens for that. just like it did for Heist. And then we need to tell the Postgres snaplet where it can find its environment. The syntax for this is slightly different. It's documented with that snaplet. So this is the kind of thing you do once. You basically copy and paste it from the snaplet's documentation. And now you'll be able to invoke Postgres commands directly out of your snaplet. And that's what we're going to do. So we have a little function here called getURLID. And what it does is it saves a URL that you give it and gives you an ID back. And that ID is going to be how we shorten it. So if we look at the type of getURLID, it's a function. That's what the arrow means in Haskell. It takes a text value, and that's going to be the URL. And then it does a handler action. In this case, it's going to do some actions to interact with the Postgres database. And it returns an integer. So this is following pretty much the same form as we've used everywhere else, except that now we're taking an argument. So what we're going to do is we're going to use a SQL command, which we invoke using query. And that comes from the Postgres snaplet. And this is going to save, the first line here is actually checking to see whether the URL already exists, because we don't want to create a different ID for the same URL over and over. So first we're checking to see whether it exists. If it does, then we just return the existing ID. If it doesn't have any results, that's what the empty list does on the previous line. If it doesn't have any results, then we're going to insert it. And then out of this SQL, we'll return the ID. That's why it says returning ID. And then finally, we return it from our overall function. So regardless of what happens during the function, you're going to end up with an ID, and that ID corresponds to the URL. Now, yet again, we're going to change how our index page works. So instead of simply giving you some canned text, what it's going to do is it's going to save your URL using the getURLID function. And then it's going to put that in our feedback dialog box. And then we're going to get a little piece of text there that tells us the ID. We need to do one more thing before we're done, which is we need to let Postgres actually initialize itself. We do that in the same initializer that we used before, and pretty much in the same way. The Postgres init doesn't actually need an argument. It takes a config file that you have to set up separately. Very simple to do, but I'm not showing that here. And so we just put that in the environment, just like with Heist. So we can take a look at that. Put in Google, it says saved with ID 2. If we put in Yahoo, it'll get ID 6. If we put in Google again, we'll get ID 2 again. So this is using a local Postgres database to make that work. OK, so now we've saved the URLs. We've created short IDs for them. The last important thing that we need to do is actually allow people to use this. So we'll just add one small library again. We don't need to change our environment. We don't even need to change the index handler, except we want to change the text, because now we've actually got a link to send them to. Instead of saying, here's your ID, we say, go to the website. And then what we need to add is another handler. So each of these pages that we create had better exist. And this is going to be the handler that makes them exist. Again, it's a handler action. And what we need to do here is first retrieve the URL ID from the request, just like we were retrieving the URL from the previous request. This time, we're actually going to parse it. This read may param function, what it basically does is it's the same as getParam, but it also parses the integer. And we do need to give a type annotation on the left-hand side of that arrow there that tells it that it's reading an integer. Interestingly enough, this is the only type annotation in this entire program that you are required to give, because otherwise it wouldn't know this is an integer. But everything else you can leave out if you want. OK, so if we do have a URL ID and it parsed successfully, then we're going to select that out of our database. We're going to get the results. Assuming that it does exist, we're going to redirect you to that URL. If it doesn't exist, or if it failed to parse, or if it wasn't sent along, then we're just going to redirect you to the home page. A little bit more marketing for us. And we don't need to change the splice. We don't need to change the init except to add this route. We just, basically what this says, the colon is actually a little bit special in Snap. That says that we're reading a variable out of the URL request. And we're going to stick that into a parameter called URL ID. That's what we just read out of. So Snap is going to take this route. It's going to find anything matching a single URL ID in that position. And then it's going to invoke the redirect handler. Don't need to change main. All right. So this is the final stage in the evolution of this website. And if we put in google.com here, again, I don't have an internet connection right now, so this isn't going to be as impressive as I had hoped.
Localhost 8001.
OK. OK. That creates this link. We can go into a new browser tab and go there, and takes us to that link. All right. So that's a URL shortener. It's written in Haskell. And that is all the code. The left is the Haskell code. The right is the HTML. And aside from a couple of images and stuff, that's all it is. All right. Any questions? All right, go ahead.
You had snaplets nested under memoize init. Would you ever have two root snaplets?
I don't think that you can use two root snaplets. That's the run snaplet function only has a place to take one snaplet.
That makes sense.
Yeah. Anyone else?
I suppose.
Go ahead.
Why do you prefer Snap over some of the other options?
Well, I investigated all three of the major ones, Hapstack, Yasod, and Snap, a couple of months ago. I can't say I have anything against any of them. I landed on Snap probably because it was the last one I tried, and I just kept going with it. And it works really well. It's really fast. It's got a lot of really easy to use functionality. You can talk to Doug if you want to hear more about Snap. Go ahead.
Now, for deployment, would you use
Yes.
like data files, the Cabal feature, like data files, and compile it on the remote machine to install it in the right place? Is that what you would do?
Yeah, you could. The deployment of this is it can be really straightforward. You can do more advanced things. The way that I deployed this particular application is I just copied the binary and all of the resource files up to my server, and I just ran it. It was very straightforward deployment. And if you're doing a serious deployment, you probably want to have a little bit more management infrastructure than that. But the nice thing about this is that you don't have to use anything complex. You get a Haskell binary, in this case a standard Linux binary. You can just invoke it. It's got built-in command line switches for changing the ports. Some of you may have noticed that I'm running all 9 versions of this simultaneously on different ports. I didn't have to build any of that functionality. That's just a command line switch. It's got logging built in. It's got a lot of stuff built in. So you can take it anywhere from very simple deployment to something way more complex.
So you didn't have any path, like absolute paths in there, just running in the same directory.
Well, these are actually all running in different directories. It's all relative paths.
I mean, the resource files are in the same directory as the bind directory.
Yeah, that's right. In this particular deployment. Yep.
What's up with that syntax of make lenses?
Make lenses is actually a template Haskell invocation. It's actually running at compile time, and it's generating Haskell source code. So you may have noticed the two. Let's see if I can find this. Yeah, so you can see here it's not very easy to see, but it's got two single quotes before it. That actually is sending the name memowise to this meta function, and then it's going to use that to generate lenses from the data structure. Lisp people will be familiar with this kind of stuff, but it's not too commonly used in other languages. All right. Okay, well, I guess we should probably take a break, and then Doug will come on with his presentation. All right.
Take like 2, 3, 5 minutes or something, I'll get set up.
All right.